Chris, and in this physics video we're going to take a look at a kinematics question. Kinematics basically have to do with the way that things move. So we're talking about velocity, acceleration, change in position, and things like that. Let's take a look at this example. How long does it take a car at rest to accelerate to a speed of 20 meters per second if its acceleration is 5 meters per second squared? Okay, well first of all, in this question, we want to jot down, and this is true of any kinematics question, it's a good habit to develop, you want to jot down the different variables that you have and the values that you have for each one. So at first it says how long does it take? So they're asking about time, and because that's what the question's asking us for, we don't know time yet. That's something we're going to have to figure out. So how long does it take a car at rest? And that's key there, a car at rest, because even though we don't see a number written down, we can take some valuable information from that statement. If something is at rest, it means that its velocity, in this case it's v initial, because it's where we're starting from, we're starting at rest, it's going to have a velocity of 0 meters per second. It's not moving to begin with. Now we press the gas pedal, and we are accelerating to a speed of 20 meters per second. So this represents our final velocity. The 20 meters per second is going to be our final speed. We're going from 0 to 20. So here we plug in 20 meters per second for final velocity. And it says if its acceleration is 5 meters per second squared. So for acceleration, we're going to plug in 5 meters per second squared. So these are the variables that we know. I'm going to include one more, even though it's not mentioned in this question, they're not asking for it, but it's something that we do see in a lot of kinematics equations. I'll plug in a value for delta x, which represents change in position, and here that would also be a question mark, because we don't know the value of delta x for this. So if we were to try to solve for this, we want to figure out which of our kinematics equations we should use. And there are 3 that you probably have been exposed to in class or seen somewhere in a textbook and should get in a habit of memorizing if you haven't already for dealing with these kinds of questions. So I refer to these as the big 3, and we'll take a look at the big 3 right here. One is that velocity equals initial velocity plus acceleration times time. And the other 2 are a little bit more complex. So one equation that relates these values to each other is v squared. And when we write v really represents v final. So you might see it written like this with the f included as a subscript for v final, or you might just see it written as v, but that's what it represents. So we have v final squared equals v initial squared plus 2 times your acceleration times your change in position. And lastly, we have change in position represents initial velocity times time plus 1/2 acceleration times time squared. So for this particular question, we're being asked for time. So if we take a look and see which of these 3 equations we need to use, first of all, we know that we need something that has time in it somewhere. So this first equation has time, and this last equation has time, but the second one, we know that we can eliminate that one right away, because it doesn't have t anywhere in the equation, and therefore we wouldn't be able to use that to solve for time. Now, to evaluate whether it's equation 1 or 3, which one of those we should use, we want to take a look and say, okay, if I'm solving for time, that means I need to have everything else so that I'm only missing one variable. So in this first equation, I have final velocity, yep, I have a number for that. Initial, yep, we have a number for that. And acceleration, we have a number for that as well. So we actually do have values for everything besides time, which means this first equation will work out for us. The reason the third equation doesn't work is because we are missing a key component of that. What variable are we missing in this last equation besides time? So if you look at our list here, if you said change in position, you're right. We don't have change in position for this, and therefore we can't use that third equation. So we know we're using that first equation, and if we go ahead and plug in our values to that equation. V final is 20, V initial is 0, acceleration is 5, and t is the variable we are solving for. There's a 0, we subtract that, we're left with 20 equals 5t. Once we simplify, divide by 5 on both sides, and 4 seconds is our value for t. That's how long it would take us to accelerate from rest to 20 meters per second at a rate of 5 meters per second squared. If you have further questions, please feel free to watch our other physics video. You can visit our website at sandersontestprep.com, or you can watch STP TV, where we have other physics topics covered and other similar questions to this with more complex calculations involved. Thanks for watching.